Just like we have operations of addition, subtraction, multiplication, division, exponents, absolute values, sine, cosine, tangent, logarithms, all those things, we introduce another operation, and it is called composition. This reads f of g of x. And as you may have trouble understanding what that means, it literally means f of g of x, which means that you put a function into the domain of another function and evaluate it. Okay, so here's what's happening in terms of our maybe our function machine. We have g and we have f. We take a domain value of x and we plug it into the function g. Function g gives us an output, a range value, and we call that g of x. But we're not done. We then take that g of x, which in turn becomes a domain element for f. We plug it in, and we get an output or a range element of f, which happens to be f of whatever g of x was. Same. The circle is not at times. So when we think of, just understand that if the circle was 8 times, then we would be using a multiplication symbol. It is an operation. It is different from addition. It's different from subtraction. It's different from division. We cannot say it is one of those operations. It's a new one. So here's what I think of the circle as. I think of it as the word of. F of. And maybe that's why they use the little circle, the emphasis on the O and of. Or maybe it's the emphasis on the O in composition. I'm not sure. I haven't researched why we came up with that, but that's what we get. So let's see, let's try to evaluate a few problems. It says f of g of 0, which, by the way, is the same thing as f of g of 0. Those are the same. You don't have to write it when you do the problem. I just want you to understand those are the same. So in this problem, what do I do with the 0 first? I plug it into g, and what do I get? I get 0. So g of 0 becomes 0. What do I do next? I plug 0 into the f function, and I get -3. And that's it. Not too bad, but it is new. So if you saw that on the ACT, you might be like, I'm totally confused. I have no idea what I'm doing. Really not too bad. Okay, now let's switch it. Okay, we've got f of g. Here we have g of f. So they switch places. Is 3 times 5 the same as 5 times 3? Yeah, that's commutative property of multiplication for real numbers. Well, this isn't multiplication, and this isn't real numbers. This is composition, and it's functions. So commutativity might exist. It might not. Let's see. What do? 0 for f, and we get -3. Then we plug in -3, and we get -3 squared is 9, minus 6 is 3. So, did we come up with the same result? No. They're opposite. They're not always opposite. Composition of functions is not commutative. It is not. So order does matter. Okay, C. It's no different. It's just f of g of -2. That's all the problem is asking us to evaluate. So what do I do with that -2? -2 squared is 4, minus 4 is 0. So then I do f of 0, which according to our previous problem says it was -3. I'm not going to write this next one out. We'll try to understand it just as it's written. What do I do with the -2? Plug it into f. When I plug -2 in for f, I get -4 minus 3 is, so I have g of -7. Now I take that -7 and 49 minus 14, 35. Yes, so this is saying that you plug -2 into f first because it's closer. Yep, that's what it's reading as. You try E and F on your own. Okay, I've got -5 and I've got +15. Does that look good? Now, on the test, some of you will just want to write the answer as opposed to say f of -1 as well. At least if I see f of -1, I know that you got out a -1, and I can see maybe where your mistake is, try to give you partial credit. But if you just go to your, test, you just write down 8. If this is worth 2 points, then, I really can't give you a point because you're wrong, and I don't see any work. See what I'm saying? All right. What makes G different? Yeah. So what do you think I do? I plug x into the G function for x. And what do I come out with? Yeah. X squared plus 2x, right? So then what do I do with the x squared plus 2x? Yeah, so I have 2 times x squared plus 2x minus 3. 2x squared plus 4x minus 3. Try the next one on your own. Okay, 4x squared minus 8x plus 3. So I had to take the 2x minus 3 and I had to square it, and I also added 2 times that. Okay? Because again, the rule for g of x was x squared plus 2x. So I had to take the 2x plus 3 and plug it in for each one of those. For each one. Jackson, question? Okay. Anybody else? They may make a mistake that they'd be willing to share. Cole. Okay. So some people, first hour when they squared this, they just got the 4x squared and plus 9. They didn't do the -12x in the middle. Okay. Some people got a -6x in the middle. Make sure as you're multiplying that out, you double the middle. Okay. All right, we won't do the bottom two. Flip it over. I would like you to draw these two graphs as you see them here. You might want to draw one that's light and then one that's dark so you can tell the two apart. Okay. So part of the AP Calculus standards that some of you will see next year is that when we look at some of the mathematics, we don't simply just look at the analytical approach, which means sometimes the algebraic expressions, but that we would also look at problems graphically, and we'd also look at them by examining a table. Okay. So I don't have a table example here, but I do have a graph example. Note to self, put a table example for next year. That'd be helpful. Okay, so we're going to do a number of function operations. We do f plus g of 2. And in order to compute that, all we need to do is just f of 2 plus g of 2. What is f of 2? Problem says so. It's okay. If I plug in 2 to f, it has an output of -2 plus +2. -2 for f, +2 for g. Add them together, 0. G minus f of 0, g of 0 is 2. F of 0, 0, and I get 2. F times g of -1. F of -1, 1. G of -1, I get 1 times 1, it's 1. f divided by g of 0. 0 divided by 2. And that is 0. F divided by g of, or I'm sorry, f of g of 1. Now here's where we get to a new part. So what do I do first? Right, g of 1 is positive 3, right? So once I find that output, what do I then do? I create that as an input for f, and I get negative 1. So g of f of negative 2, I plug in negative 2 for f, and I get 2. So then I will take a value of 2 and evaluate it for g. And I get 2. What do you think? Not too bad? Okay. Your assignment, 2.8, page 225, number 17 through 34. Looks like a lot. Some of them are very, very quick. You just plug them in for one, plug them in for the other, and you are done. You can actually, tell you what, you guys could all get the assignment done before class is over. I'm confident that that could happen.